In this video, we're going to do an application of systems of equations. And this application is going to have to do with selling tickets for a basketball game. It says 800 people attend a high school basketball game, and total ticket sales are $3,102. If adult tickets are $6 and student tickets are $3, how many adults and how many students attended the game? Okay, so what we have to do first of all is define variables. We're trying to figure out how many adults and how many students attended the game. So I'm going to let X be the number of adults, okay, that attended the game, and Y will be the number of students that attended the game. Okay, so you always have to define variables when you're doing an application like this. Now, we also have to come up with some equations. Now, we know that 800 people attended the game, so what that means is that X plus Y is 800. Okay, the next thing that we know is that the total ticket sales were $3,102. Well, if the adult tickets are $6, then 6x tells you how much money came from the adults. Okay, and if y is the number of students and the student tickets are $3 each, then 3y is the total money coming in from the students. So 6x plus 3y should equal $3,102. Okay, and now what we have is a system of two equations and two variables. And we could solve this a couple of ways. Let's solve this using the substitution method. Let's actually solve this for y. We would get y equals negative x plus 800. Okay, just subtracted x from both sides. And if we plug that in for the y in the second equation, what we get is 6x plus 3 times the quantity minus x plus 800, and that's equal to 3,102. So I plug this in for y in that second equation. Okay, now what we have is just one equation that involves one variable, x, so let's solve it for that variable. We're going to distribute the 3. We get plus a minus 3x, or just negative 3x, plus 2,400 is equal to 3,102. Okay, now 6x minus 3x is just 3x, plus 2,400 is equal to 3,102. Now subtract 2,400 from both sides, and what we end up with is that 3x is equal to 702. Okay, and if we divide both sides by 3, what we get is that x is equal to 702 divided by 3, but that is 234. Okay, 234. So what does that mean? X is 234. Well, let's go back and look, and what did X mean? That was the number of adults. Okay, so how many students are there? Well, let's take this equation, x plus y equals 800. Okay, x plus y equals 800. And we know that there are 234 adults. So how many students were there? We'll subtract 234 from both sides. We get y equals 500 and let's see, what would it be? 66? 566. So 566, that is what y is. That's the number of students. Okay, so what we can say, it's nice to say this in words, we have 234 adults and 566 students. Now, it's always good to check to see if that answer makes sense. Well, is that a total of 800? Yeah, add these up. That adds up to be 800. And also, if you think that if you know that the tickets for the adults are $6 per person, you could find out what 6 times 234 is, and that would be what? Let's see, 1,200 would be 1,300. Actually, let me do this on a calculator here. Okay, 6 times 234 would be $1,404. Okay, that's how much money is coming in from the adults. And the student tickets are $3 a ticket, so 3 times 566, that would be $1,698. And so $1,698 is coming in from students, $1,404 from adults. What is that total? Well, if we add this up, we get 2, carry the 1, that would be 0, 1, 3, $3,102. And notice that's the total amount of money that did come in. So we did this correctly. Okay, so the first thing you do is you define your variables to be the things that you're looking for. I call them X and Y. You could have called them A and S for adults and students, but whatever you want to call them, it doesn't matter. And then find two equations that relate the two variables, and you find the two equations based on statements. 800 people attended the game. Okay, total ticket sales were this. You use those facts to set up a system of equations, then you solve it.